So with me now is Katherine Kuchenbecker, a mechanical engineering professor here at University of Pennsylvania. Welcome.
Thank you. It's great to be here.
Thanks for spending the time. So tell us a little bit about what you're involved in, because before we fired up the camera, it sounds like you're involved in about 15 different things at once.
Yeah, so I specialize in the field of haptics, which is a sub-area in robotics that deals with the sense of touch. So an agent, maybe a human or a robot, interacting with its environment physically, touching it. And one thing we work on is how do we make autonomous robots more smart with their hands to be able to do things like put dishes away or clean up your house or maybe help do other tasks like disarm a bomb on its own. And there's a lot of skills that humans have in their hands that robots aren't quite there yet. It has a lot to do with the sensations you can feel in your skin. So that's one big area of work that we do. We also work on systems where a human controls a robot from a distance, like robotic surgery, that enables surgeons to reach into the patient's body through tiny incisions with these long, thin tools that have robotic wrists. And we work on how to let the surgeon who's controlling those robotic tools feel what the robot feels as it's operating, say, removing a patient's prostate under the control of the surgeon. And then the third category of work that we do is to develop haptic interfaces, devices that connect to a computer and simulate some sort of physical interaction for a human. Now this might be for a game, or it might be to teach the person something new. Like if you're a doctor and you need to learn how to give an epidural, which is where you take a 10-centimeter long needle and push it into a patient's back, we'd really like you to be able to practice that in a safe environment so you know what it's going to feel like, how hard to push, and when to know when you should stop pushing so you don't hit the patient's spinal cord. And so we work on mechatronic, electromechanical systems that simulate experiences, physical experiences like what I just described, to provide good instructional opportunities for clinicians and a variety of other applications as well.